anything else for the morning because everybody made trash last night. If you would so kindly introduce yourself and just roll with it.
Yeah.
That would be lovely.
All right. Thank you. So anytime? All right. Good morning, everyone. My name is Guillaume, and today we'll be talking about iOS URL schemes, and that's Apple iOS and not Cisco iOS. The reason why the I is uppercase is just my font was not good. So,
I apologize. I am so sorry. It's the resolution of the display changed with this, and your slides look incorrect. Is there a way to tell the slide? I do apologize. No, I mean in the presentation software.
Yes.
Can we tell it to present at a different resolution?
Oh, God. Yeah.
Oh, really? Yeah. Oh, dear. Yeah. Okay, so it just means that the slides are not going to look quite right. I do apologize ahead.
On the recording, you mean, because they look good there.
They look good here.
If you want, I can probably provide them to you in a different format after.
Okay, again, I do apologize for that. I just wanted to make sure that, for the recording and everything, it all looks
Okay.
as good as possible.
All right.
Thank you very much.
Testing.
Right, so you're going to need
Oh, there's no speakers, right? One, two. Yeah, they're working. All right. So take two. My name is Guillaume, and we're going to be talking about iOS URL schemes. So I already made that joke, so I won't do it again. So if you're an iOS user, have you ever wondered how communication between applications works? Most applications feel pretty isolated, like they're little islands, and you do your stuff, you move to a different application, you do some other stuff. But in some cases, a small amount of data is passed from one application to the other, and magic happens, and it makes you save a lot of time. So a really basic example that I'm going to show here is just you're using Google, and you're looking for bars in Las Vegas because, of course, you need Google to find one. And as soon as you find one, what you want to do is call, maybe to make a reservation. So this application, that's just the Google app for iOS. As soon as you click on the call button, it's going to prompt you and say, do you really want to call that place? And then you say yes, and the phone call is placed. So you didn't have to type in that phone number, and you just save a bit of time. So what are the different methods an application can use to exchange information? We got a few. There's the cloud, and when I say the cloud, I don't mean iCloud, because iCloud is really sandboxed. So iCloud is good for sharing data between the same application on multiple devices, but it's not good to share data between different applications for now. There's the pasteboard, which is similar to a clipboard on iOS. It's not really meant for inter-app communications. Then we got hacks. What I mean by hacks is stuff that's not meant to be used for this, but that some applications have tried in the past. For example, storing contacts and reminders as configuration data so multiple apps could read them. That works fine, except Apple is going to pull the application from the App Store as soon as they notice, so that's no good. Then we got the open in menu. I'm sure a lot of you do that, like you email files to yourself, then you do open in a Dropbox and do that, and then you end up with multiple copies of the same file. So that's not really good either. We have AirDrop, only good to send data between two devices, not between two applications. So what we're left with, and this is clearly a case of using whatever we have available, is URLs. So today we'll see what these URLs do, how they work. I'll show you some good examples and bad examples of how to use them, ideas for using them more securely, and I'll show you how you can find some more vulnerabilities in these URL schemes. So what they do is implement very basic communication between applications. So you have a source application, you have a trigger. A trigger could be a user clicking a button that says, send this to my to-do list or send this to my notes. You got a destination app that receives the data, handles it, and that just enabled a workflow. So how does the source application know what the destination application is? When applications get installed, whenever you install an application directly on an iOS device or through iTunes, it's going to register its handler. A handler is basically like HTTP : / in a URL, except the applications can register pretty much anything that they want. So are these registered handles unique? Well, not really. There's a few you can't ever reuse. These are the basic schemes that just come pre-installed on iOS. No application can reuse these, and that's one of the reasons why you can't change your default mail browser on iOS, because you can't just take that mail scheme and use it for yourself. So these are pretty simple. The mail one is just like on a PC, it's mail to, so you click on a link, it pre-populates an email. The telephone one, which we saw before, is just passing a phone number to the telephone application. SMS works the same, and it works with iMessage as well. So these are all pretty simple. Then we got some slightly more complicated ones, like maps. If you have a restaurant, for example, you could have a button that would send a user to the Maps app and trigger the directions to that restaurant. iTunes has one. Has anyone ever ended up on a not so kind of shady looking website that just redirected you to the App Store so you would buy like a crappy Flappy Bird clone or something weird like that? That's what is used for that. They use the iTunes URL scheme to do that, and they do that because they get money from all the purchases that you make on the App Store. And then we got FaceTime, which we will see in more details later on, that can be used for audio and video calls. Then there's some even more advanced use cases that enable two-way communication. So what we see here is an application called Day One. It's a diary application that does not really encrypt your notes. So what you want to do with that is obviously you want to store that in Dropbox, right? So this application knows how Dropbox works. And in the settings, you will see there's an option to enable Dropbox synchronization. So as soon as I click on that Dropbox button, it's going to send me to Dropbox. And as soon as Dropbox appears, it's going to ask me, do you really want to grant this Day One application access to this folder? And as soon as I click allow, Dropbox knows how to send the information back. Everything's enabled. I didn't have to go to Dropbox.com and give permissions or do anything special. So as a user, that was fantastic. That was easy. That was fast. Was that secure? Well, different story. So as we do automated workflows like that, what can happen is over-automation. So the example I'm going to show here, this application is just a launcher. So these icons that you see, they're just URLs. There's nothing funky going on in this application. So as I click that, you'll see really quick a calendar application flashing. And then I'm on the B-Sides website. So what happened? I go back to my calendar, and I have something that tells me I need to crash the Nike party. Because why does Nike have a party at Black Hat? That's just weird. How did that work? Okay, so now I'll click the real link. And again, it flashes really fast. I'm in Safari. What happened? I go back to my calendar. Now I got 2. So it just created an item in my calendar. And this is fantastical, a pretty popular third-party calendar for iOS. And I saw it flash by, but no user interaction was really needed. And why is that? Well, that's because the developer, when he made this application, added kind of an evil bit. And that evil bit is add equals 1. When you add that to whatever data you send to it, it's not going to ask for anything. It's just going to do it. So, okay, that's just a calendar. That's not really dangerous. It could be annoying if I set it to wake you up at 5 a.m. in the morning tomorrow. How did I send that back to the B-Sides website? It's because the application supports a standard called X-callback URL. That's just a standard that developers have been using to send data to one application and then receive the response back so you can have more advanced workflows. So the attack surface grows. The more stuff we add, the more potential for something to go wrong. So this example, which I borrowed from a website called MacStories, is just to show you how big the attack surface can get with these things. So what we see right now is just a standard iOS browser. Someone has just selected a piece of text, is going to click on a bookmarklet in his bookmarks, which is just a piece of JavaScript code. This JavaScript code took that text and triggered a URL scheme for another application, which is a notes application called Drafts. This application runs Python. That's what you just saw up there, because yes, you can actually execute some other languages on iOS now. Once that application is done, it triggers a different URL scheme that sends that data to a to-do app, where the guy can put this URL, add a little comment, and when he's done, he's just going to say add, and it's going to ask him, do you want to go back to your browser? So in this example, we had a browser, JavaScript code, a notes application, Python code, a to-do list, and then back to the browser. So there's a lot of potential for these things to go wrong. So the first person to find things going wrong with these is Nitesh Dhanjani. In 2010, he found an issue with Skype that you could use to place a phone call with Skype with no user interaction. And he posted about that on his blog and on Sans website. But Skype back then was one of the very few applications that used that, so we didn't really hear more about that since 2010. And the most interesting thing he found, and you can't see it on that screenshot right there, so here's the code. he found that Safari will execute any URL scheme automatically if it's located within an iframe, an inline frame. So all the stuff I was showing before could be triggered as you're browsing a website. And that's the second part that these kind of crappy websites use to send you back to the App Store. So I figured, what can I do with that that would be a little bit more evil than that? So I looked at all the applications I had on my phone, and I found this first one. The application is called Byword. It's a really good text editor for Mac, iPad, and iOS. And it had a feature to overwrite a file using a URL scheme. That sounded weird. So it looked like this. By doing this, you would replace the file important.txt in iCloud with the text for the lulz. And the previous file has been overwritten. And unlike Dropbox, iCloud doesn't really let you go back to a previous version. So that's permanent data loss for most users. And iCloud is pretty flat, so guessing that someone might have a file called notes.txt or todo.txt or important.txt doesn't sound that hard. So I reported the issue to the vendor. They acknowledged within a few weeks a patch was out, but the patch is just, there's a warning sign now. So it basically goes, are you sure you really want to destroy your data? And then if you say yes, well, then it just does it. So I guess it's a little better than it was before, but not much. So the next day, I looked at some other applications I had on my phone, and Tweetbot is one of the most popular iOS Twitter clients. And it had a scheme that allowed you to follow a user. So my first thought was, oh my God, all my friends are going to be following Justin Bieber soon. And that's the exact code. So I notified the vendor. They acknowledged that this was a security issue. It took them a little while. They released a paid upgrade which fixed the issue, and then they went back and it did fix the previous version. So that took a while. And from a security perspective, that's not the end of the world. I mean, you just followed someone, you can unfollow them. So why is it so bad? Well, it's really bad for your privacy because Twitter can send you notifications when someone has just started following you. So even if you unfollow them, they know what your Twitter account is. And if you mix that with the fact that Safari will execute these automatically, that's a really good way to identify a website user and de-anonymize them. So here's what it actually looked like. So what we see here is a phishing email. It just says something about a Canadian mayor smoking crack. So you should know it's phishing, right? That's so far-fetched. So I'm just going to highlight the video link. It just shows that the URL I'm clicking on is a perfectly normal, valid URL. And as soon as I click it, you'll see Safari flashing really fast with a troll face, and then I'm sent to Tweetbot. And at the top, and there's a little cropping issue here, but you can see you are now following Justin Bieber. And that happens really fast, and there's nothing you can do to stop it once it starts. So I just unfollowed him, and fun fact, I tested that like hundreds of times, and I never got banned by Twitter for it. It seemed to be a weird use case. And then I thought, how could I make this even worse? Automate it, maybe. Could I use ad networks and embed these inline frames in there and get a lot of people to follow me or follow someone else? That would be pretty evil. But I figured there's not enough people that use Tweetbot. I know a lot of people that do that, but that's just because I know a lot of geeks. Most people just use the standard Twitter application. So that wasn't what I really was looking for. So I get back to my phone and I look at the applications I have and I figured what's more popular than Tweetbot that I have that could be used for this? And I found FaceTime. Pretty much everyone who's got an iOS device uses FaceTime, right? The issue is really similar to the Tweetbot one, so it's a really important privacy risk because it affects most iOS users. So what happened is FaceTime used to be video only in iOS 6 and previous versions, and they added FaceTime audio in iOS 7. The video calls would ask you for confirmation before placing it, but the audio calls did not. I don't know why. And I also don't know why they called it FaceTime audio. That's a really stupid name. They should have called it VoiceTime, which would be much better. So this inline frame on any website would make you call me. That's my email address. That's my iCloud account. Please don't hack it. So that would call me. And as soon as the call is placed, I see the caller ID information. So if you're using your iCloud email address, I see that. If you're just using your phone number for FaceTime, I see that. So if there's anyone that's got iOS 7 to 7.06, or that's got the latest version and has Chrome, well, demo gods plus AT&T roaming equals 2% chance of success. But if you browse there during the talk, that's probably going to call my phone, which is on mute, so we can do a small live demo. But I got a video of what it looked like. So you can see my wonderful office on the right. On the left is my iPad. So I'm just browsing a website. And I'm just clicking a link. I know you don't see the text, but it's not really important. And as soon as I click on that link, the recording stops on my iPad because it doesn't let you record when you're placing a call. And on my phone, I see my name. I would see the email address or the phone number, but I have myself in my contacts, which might sound weird, but it's just so I can send it to other people. And it happens really fast. Even if you hang up, your caller ID info is already there. So I looked at Apple's secure coding guide, and what did it say about these URL schemes? They say, whether you make the comments public or not, hackers will try sending comments to your application. And I think that's like the history of the world. You just made something, someone is going to try to break it. And then what did they do? They fixed Safari. So Safari prompts you before calling someone. But there's a whole bunch of other applications that are browsers on iOS. And the issue is not fixed for these guys because it's not the FaceTime application that's been fixed. So I looked at the browser I had on my phone, the browsers I had on my phone, and I had a few that I use quite a bit. So 1Password, really good guys. They're like, yeah, this is really bad. They fixed it super fast. The second one is Onion browser. It's an unofficial Tor browser for iOS, not the bad one that was malware, the real one. So I spoke to the developer. It was not impacted, and I said, hey, did you think about this? Is that on purpose? And he said, no, I didn't have time to implement the external URL scheme stuff. But when I do, I'll make sure that we're really careful with what external applications we launch because the user is in Tor only in the browser because it's iOS, so it doesn't get done at the network, at the system level. And Google said, that's not really a Chrome problem. That's more like a Chromium problem. I'm like, I don't really care that there's an issue. Maybe someone should fix it. And then they sent me to a thread where people say this can't really be used maliciously, so they don't want to add a warning. I think I prove it could be used maliciously, but whatever. They're kind of right that Apple should fix FaceTime. Then I looked at the Twitter application, the real Twitter application, which has a built-in browser like so many other applications do. So if you want to know who a Twitter user is, just send him a link that's got this inline frame that I showed before. So as soon as he's going to click on that link, the call is established and you know who he is. So if you need to know someone's phone number, it's really, really useful. And that's going to work in every application that's got UI WebView and WebKit pretty much. Maybe it's going to be fixed eventually, we'll see. Then back to the secure coding guide by Apple. They say, don't implement useless features, which sounds really basic, right? Don't accept arbitrary URLs and paths because you could really easily have path traversal issues with these URL schemes. They also say watch out for buffer overflows because all iOS applications in the store right now, they're all Objective-C. So there's big potential for buffer overflows there. And Apple's not going to protect you. If your application receives data using these schemes, they're just going to send the data to your application, so you can't rely on them protecting you. Don't pass these to queries because you're going to end up with query injection in your application, and that would be really bad. And they also say watch out for social engineering. Pretty much everything I've just shown is just that. I mean, there's nothing technical in these issues. It's just like a logical flaw. So don't implement useless features. Developers on iOS, I don't know, they seem to really like these URL schemes, and they use them in a weird way. So this is pcalc, a really popular third-party calculator for iOS that does RPN, and it's pretty awesome. So I'm just typing in some stuff, and then I browse a page that does clear all on my calculator. Why would I ever need a website to do clear all on my calculator? And that's not dangerous, that's just dumb. Then I found another one, and if you have issues with flashing lights, I would recommend that you do not look for the next 20 seconds. So there's an app that's a flashlight application that's got a scheme to trigger a strobe light. What's the use case for that? Like you really need to throw down a party like right now using a link on a website? I don't know what the point is. But I spoke about Twitter, I spoke about iMessage. That's all old stuff, right? The new hotness is Yo. So I looked at Yo, really secure, really useful application. And everyone's using Yo, right? So I just loaded it up. It says, invite your friends because that would be so much better. I'm like, yeah, I don't think so. And then I go browse this website, which automatically sends a Yo on my behalf because they just accept that and they do it. So I just send it to myself for purposes of the demonstration, and I just sent a Yo. So if you need to de-anonymize anyone who's using Yo, that's just one of the many ways you can do that. And what's really dumb is it's so basic. That's the URL scheme for it. You just put someone's username, and when they browse, it just sends a yo. And there's a guy who's doing two-factor authentication using yo. So after OAuth, we now have auth yo. And it's kind of a joke, but at the same time, some people are like, yeah, this is cool. We should use that for two-factor. Yeah, don't do that. Then I started looking at some other ways you could use these to de-anonymize people. So what you see on the right is my Mac. I'm logged into Google Apps. I'm creating a Google Docs that I made public. On the left, you see my iPhone. On my iPhone, I'm not logged into Google in my browser. So what's interesting is you can see these things as persistent CSRF attacks, right? Because people don't log out from applications. No one logs out from their Dropbox application on their phones. That doesn't make any sense. So what I did right here is instead of sending the link to the public document, I sent a link that uses the URL scheme for the Google Drive in the Google Docs application on iOS. So instead of opening it in the browser, it opened it in my application where I'm logged in. So on the right, it's really small, but what you see in green is my name. So again, another way you can know who I am if I'm using iOS. So what I would say, if you're a developer, have you considered that this could be completely useless? Has anyone in this room really implemented like customized workflows using these URL schemes? There's me, and I'm like a big Apple nerd. So don't do that if no one is going to use it, or at least give the user the option of not enabling that and leave that off by default. You should just have an option. Do you want to enable these third-party applications to send data to your application? Yes. If someone is enough of a geek to use this, they will find your setting. If you need full automation in the flow, for example, the day one example I showed where it just sends you to Dropbox and then Dropbox sends you back, have you considered using a key? And what I mean by a key, I mean like the cheapest, crappiest CSRF-like token ever, or a password. So just tell the user to set up a password that will be passed in all of these URLs. So that would defeat pretty much all of the web attacks that I've demonstrated, because that's not really targeted. So even if it's just 1, 2, 3, 4, 5, 6 as the password, this is really hard to brute force over the web page. So that would be pretty good. And most of all, don't rely on the browser to protect you against this. Even if it's your own OS, I think Apple should know that they've been approving applications in the App Store that have browsers in them. So how do you know an application has a URL scheme that you might want to exploit? What you can do is download the application on your Mac. This can work on a PC as well. Just extract it, show the package content, and find the info.plist file. And that's what it looks like. So what we see right here is there's a setting that's declared that says CF bundle URL schemes. And then you know the application has a scheme, but you don't really know what the scheme can do. You know it's there, so then you can start messing with it. But if you want to save a lot of time, buy this application, Launch Center Pro. That's the launcher I was showing earlier. This application has information about pretty much every application in the App Store because everyone wants to be featured in that application. So in one plist file that you can find the same way by extracting the application, you have that same information but for thousands of applications. And I'm serious, if you look at that for 5 to 10 minutes, you will probably find a vulnerability in an iOS application that just has some crazy schemes that do crazy stuff. There's other attacks you could do with that. Buffer overflows that I mentioned before. If you want to try buffer overflows using URL schemes, I really recommend that you Google Patrick Wardle's talk at Source Boston. It's available on the web. He gave a lot of good tips on how to reverse engineer iOS applications, and that would be really useful for you. And Daniel Meyer has a tool called GIDB that's on GitHub. It automates so many black box pen testing workflows for iOS, one of which is fuzzing these URL schemes. So if you have a jailbroken iPhone, it's just going to fuzz that, run the application, no error code, kill the application, and try over and over until you find a buffer overflow or a different kind of issue. Another thing that I want to try is sniffing. I mentioned earlier that these URL schemes are not unique except for the default ones. What does that mean? That means that if you know an application has registered, for example, to-do column // you can make your own application that's going to register the same stuff. And the latest application that was installed is going to receive that data. So if you know an application is sending sensitive data doing that, maybe you just want to buy the source code to one of these crappy Flappy Bird clones, distribute it, but when you receive that data, you just send it to your server, and then no one knows what happened, and you just stole some data from iOS users. Apple will probably pull your application, but that's going to take a while. Before I finish, a small note on iOS 8. It's going to introduce a lot of new methods for inter-application communication, which are probably way more secure, but the attack surface is going to be huge. And one thing to remember is the old crappy methods will still exist. Tomorrow morning, iOS 8 is released. This is all still going to exist for a long time. So before I finish, for questions, I'd like to give a special thanks to the B-Sides mentor program, especially my mentor, Brandon, who helped me make this presentation much better. And I'd like to thank you for your time by showing you an actual really useful URL scheme workflow that allows you to Google for animated GIFs. Yeah, I pronounce it GIFs. And iMessage them to your friends automatically. So that's automation for you. So thank you for your time, and I think we still have a few minutes for questions. Yes? Yeah, it is. They kind of confirmed that they're looking at it. So I'm hoping it's going to be fixed soon. When I told them about the FaceTime issue, they were working really hard on iOS 7, which was a major release, so it took quite some time for them to implement the first fix, but I'm confident they will do something about that. We'll see. Yeah, Safari in 7.06 is broken. 7.1 is fine. But like if you're using Chrome, you're still vulnerable to that, even if you're in incognito mode, right? Because Chrome still sends you to external applications. Yes? Yes, yes. So actually, you're right. FaceTime is broken. But if you're a Chrome user, you're vulnerable to that. Just making it clear that FaceTime should be fixed. Another one, yes?
So if two apps reach the same
yeah.
URL scheme, then the bigger one?
It's kind of random. Like, I tried to test, and to be sure it's always the latest one, but in some cases, it was the first one. Maybe it's random. Maybe it's random, but it's not always the first one. And some people make like paid upgrades for their application. And Tweetbot is a good example. Tweetbot has its own scheme. And when they released the new version, it was a separate app that also registered the same scheme. And if you had both apps on your phone, it was just crazy. It was always going to the old one and it was going to the new one. I don't think there's any logic behind it. Or there wasn't in iOS 7.06 when I tested it. Yes?
So other than fixing their own applications, what now do they do with this without breaking the business?
Yeah, well, I think the responsibility is in the developer's hands, right? If you're going to use this, you need to be careful. The new methods that Apple is going to provide in iOS 8 will actually be way more powerful, even at a functional level. So I think developers will start using the new stuff. So this year we should see less and less URL schemes being implemented in applications, and it's probably going to slowly die down.
Let's be clear, Apple could fix everything tomorrow by requiring a confirmation before any URL scheme.
Yes, but if they did that, that would break a lot of automated workflows, which only a small fraction of users do. But there's a few people trying to use like iPads to replace laptops and day-to-day application. So until iOS 8, it was such. I don't think Apple ever intended that to become so popular, but because there was nothing else, it became popular, and now they're kind of stuck with the problem because they can't just kill it. So we'll see. You can also do whitelisting. If you have an application that should only receive data from one other application, you could do that. But unless you really know exactly what your users are going to use it for, that's not really a usable solution. We still have time for one more question. Yes.
Once the iOS 8 stuff comes out, is there any reason not to just deprecate all of this other than the built-in ones like Telegram?
I think they can still be useful for really basic stuff like the telephone one, and who knows if Apple would deprecate that in maybe iOS 9, because Apple is usually not shy about removing older features. So we'll see. It could happen. Could happen. Any other questions? All right. Thank you.